So now what we need to do...
Link below.
Too small, unless we can... No, we can't. Hello, and welcome to another episode of The Art of Engineering. I am a Victor Kilo 2 Alpha Oscar Echo, the lunatic painter, and today we are going to construct and install a common mode choke. Now, some of you may have watched my video, link below, on the DX antenna that I built. It was a vertical L antenna. It has been working really well, but originally when I installed it, it was a recommendation that the antenna have a common mode choke installed. It isn't a properly balanced antenna because you've got one part of the dipole that's very low and close to the roof, and that could cause some issues with common mode current. It isn't fed with a balun, so we're not balancing the balance to unbalanced situation at the feed point as well. For all of those reasons, it's probably a good idea to have a common mode choke on it. Now, there's a heap of resources online about common mode chokes and the theory about why you need one and how they work and all that sort of stuff. So I am going to put a heap of links below this video, resources that I looked at when I was building this and trying to understand how it all works. And it is a fascinating thing, and anything you can learn about antennas and transmission lines, go for it, because that's why we do this hobby. We want to learn new things. In a nutshell, a common mode choke stops common mode current. It chokes common mode current. What is common mode current? Well, I'm glad you asked. Common mode current is the current that flows down the outside of the braid of your coaxial cable. Now, the currents inside your coax, the center conductor and the inner part of the braid, they have a balanced situation going on. So if you've got so many amps going this way, you always have the same number of amps going the other way inside that coaxial cable. Now, this is a physical law. It's a very complex thing. We're not going to try and explain it. Certainly I'm not smart enough to explain it. But I do know that if there's any imbalances happening, then it needs to flow down the outside of the coax. And what we need to do is try and stop that from happening, because if it flows down the outside, it can bring RF into the shack, causing problems with your equipment, interference, and in a worst case scenario, you can get an RF burn. So for all of those reasons, we want to try and choke that current out. Now, I've got to say, I have used this antenna up to 100 watts. I don't have a linear here. I'm normally QRP. I would say 90% of the time I'm QRP 5 watts or below. So it's not likely ever to be an issue in this shack. But occasionally I crank up the TS520 and we put 100 watts into the antenna. And I've done that on this antenna and I haven't seen any indication that there's any problems with common mode current coming into the shack. Now, it should be understood that the antenna is well matched, and a high VSWR can cause problems with increased common mode current flowing in the transmission line. Another reason why you might install a common mode choke is to stop induced current from nearby noise sources or RF sources that can induce a current in the transmission line that can then cause problems with your equipment or more noise, increase your noise floor. So by putting your common mode choke on this antenna, you might tame the antenna a little bit when it comes to noise. So let's jump on the test bench and I'll show you how I build this common mode choke and also how I install it on the roof. I think the way I install it is something that I haven't seen online. I think it's an easy way to do an install, and it might be something that is interesting for you to watch.
Okay, let's have a quick look at something that's come in the post. We always love it when something arrives in the post, and this is from my Red Bubble store. And I have bought these for myself because I wanted to see what they actually look like, seeing I want other people to own them. So we will have a look at what we have. I'm quite happy with that, so I'll pop that on in a sec and I'll do a quick model of it. ham radio shirt.
And here you have it, folks, in all its splendor, the CW shirt, a shirt that commemorates the Jedi mode, continuous wave Morse code, and it's also depicting the key that I made from Bunnings parts. That's a kitchen door handle and a doorknob and some door closing apparatus and bolts and etc, etc. Artwork by me. This shirt is based on a painting that I did of a pig that we met outside a temple in Bangkok. Parts for this project, you will need some RG58 cable. I'm using the cable that is already on the antenna. I'm going to show you why in a minute. So that's your roll of RG58. And obviously you can wind a toroid like this with other types of cable, but then you'll have to change the amount, you might have to change the amount of turns. Weatherproof box, got this one from Mini Kits. And you will also need an FT 240/43 type ferrite toroid. Now I'm going to point you to a website. I'll put the name of it down here, and it has all the information you need about winding various types of toroids and their response across the frequency spectrum, keeping in mind that you can wind air toroids, but they tend to have a lot of windings on them and they tend to be a lot narrower banded. This is a nice way of getting a toroid that's not ridiculously large and doesn't use a huge amount of turns. The plan is I'm going to feed my coax through a hole in the bottom of this box, take it out the front of the box, wind my toroid, slip it back in again, and what I intend on doing is making sure that I don't need to put a BNC on this either end, because this common mode rejection choke is going to be used on that antenna, and rather than introduce the potential for corrosion and problems with the attenuation that's going to happen with extra connectors and whatnot, not huge amounts of attenuation, but nevertheless, if you can avoid a connector, why not avoid a connector? So I will be wrapping it around this, attaching it to the antenna, and this will go inside the box mainly to protect the core from the weather. And then where it comes in and out of the box, I'm going to put a small grommet, and I'm probably going to also just bung in heaps of silicon to stop ingress of water and weather. And so rather than make it removable, the great thing about these common mode rejection chokes that are built with the coax just wrapped around them is that in the end, if it all fails, or if I want to move it or whatever, I just remove it from the box, unwrap it from the coax, and I'm ready to go again. So it's no big deal. So we have our box, and it has a rubber seal on it, which is a good thing because that's the whole idea of making it weatherproof. And we have these units to seal the holes and whatnot. Actually, they're rubber, so if I cut them to the right size, I can insert them into this box and they'll be perfect for feeding cable in and out. So that is awesome. That's what we will be doing. As luck would have it, it just fits. So what I'm going to do here is I'm going to do a dry run. We need 12 turns, and I've got my roll of coax here, and I'm just going to work out exactly how much cable I need. So when I get on the roof and I wind this on the roof, I will have an idea of how much cable I'm going to need to reserve, and I've got plenty left in the shack so I can compensate for whatever I take up in the toroid. Every time it passes through the center of this toroid is one turn, and you need 12 turns to get this all to happen. And I will direct you to the resources that I use to confirm that this is actually the correct way to do this. But there's so many people online that have done this. So this is just my take on it, my lazy way of not having to put connectors on it. So we've got 1, 2, and we go up to 6. So I'll pause it here and I'll show you when we get to 6 what we do. Now, hopefully you can see there we've got 1, 2, 3, 4, 5. When we come to 6, we cross across to the other side. And you can see here I've got a cable tie. You can get your cable ties to try and hold it in position. I'm going to be removing these because I have to take it up on the roof and do this again. But this one here would probably be your starting one, would probably be a good place to have a cable tie as well. So we cross across to the other side, and of course, when we get there, when it passes back through the center, that's also a turn. So we got 1, 2, 3, 4, 5, 6. The next turn is going to be 7. And then we just continue on to 12.
8, 9, 10, 11, 12.
That is the distance of cable we're going to require to do this common mode choke. So now what I will do is I will mark with a little bit of tape the start and the beginning of this process, so we know what distance of cable we need to wind this choke. Okay, so we put a bit of plumber's tape on here so that we know what distance cable we're going to require, and we will remove that cable tie, hopefully without chopping our cable, because it's a huge amount of cable to be wasting. I'll be quiet. So there you go. Now we just have to unravel this and see how much cable we've actually used to wind this toroid. So, you know, ye of little faith, it does fit in there, and I'm really happy about that. Because it just means I don't have to do something dodgy, even dodgier than what I'm doing now.
Pilots were complaining no end about how bad the signal was, and so I was copping flack for that. And I went out there to play around with trying to load it up as best I could.
So what I'm going to do is I'm going to measure the distance between these two blue lines. That'll tell me roughly how much coax I need to reserve to wind onto my toroid. So when I get up on the roof, this is the plan. I reserve the amount of cable that I need. I feed it through the hole in the bottom of this case to one of those markers, and then I wind. I'm being called by. Yes, I'm making a film. Wind it on the toroid, and then feed the tail out the top. Now I'm almost certain if I look online, there's probably an easier way of getting these things out, because you've got these lovely little rubber stoppers which I can drill an RG58 sized hole in the top of and squeeze the cable through, and then I can probably go with some silicone in here to make it even more weatherproof. But I am taking my life in my hands and just squeezing this blade through, being very careful not to put it into my hand. You can probably just pop them out if you know what you're doing. So if there's any electricians watching, I can probably look online and look up how to do this the correct way, but hey, I think we can just create dotted lines around the outside of it, and it'll just pop out. And these apparently squeeze in. Be quiet. And there you go. One down, and I just need one in the bottom. And I've realised that I can use one of these holes here. I was going to use it to cable tie the thing down, but what I probably will do is I will use these holes to attach this thing to the actual pole that the antenna's on, so that it's not waving around in the breeze. And I've gone for a drill bit that's quite a bit narrower than our coax. And the reason why I've done that is because when we squeeze it through here, we don't want it to constrict the coax, but it's very soft rubber in the top here, so we don't really want it to be too wide a hole. So I will drill those holes out. Then I'll quickly make sure the coax actually does fit through, because I don't want to get up on the roof and find out that it's too small. That's not going to be much fun. That's one. That's two. Squeeze it through. Yes. It squeezes through nicely. So we just need to get our coax off here. Just need to see what these look like after the time they've been in the weather. And this is the earth side. And if our box is there, we need to go about 1.25 meters this way. So we shall see how this all works out. Okay, well hopefully we don't run out of batteries. So that'll take us into the slack, and then we need to go about 1 metre from there. I said 1.25 metre, but that was taking into account the so I'm going to say to that point there. I'll just hold on to it so I know where I need to go. Yes, that's far it's going all right. Once you get it through, it's a little bit thicker because it's got solder on it. And we're going to take it up to the cable tie because that's how much we need to wind. And then what we need to do is we need to wind oh, so graceful. Where is our toroid? I did have it. Neighbour's dog absolutely loves to bark at me while I'm up here. So we need to go 6 turns. And what I'll do is I will go a bit further than I need to so that I can feed it back in again, because we don't need to make life difficult for ourselves. We can always feed it back. I'm going to throw a cable tie on the start. Now you don't want to go too tight on this, because if you squeeze your cable tie too hard, there's always opportunity to change the impedance of the cable, which, you know, kind of negates the benefits of having a common mode choke happening. I shall wind this and I'll come back when I'm ready to stick it on the wall over here. And there you have it, all wound and ready to go. I just need to now slide this back into the box. There we go. Yay! There you have it, folks. A common mode choke installed without the need to apply any connectors. It's the lazy way of doing it. One thing you can never have too much of in the shack is some cable ties. So we'll go around here like this, underneath there like that, down here like that, just I want that to be tight without being stupidly tight. Yep, happy with that. And there you have it, folks. I'm not going to chop that off because I know what will happen. I'll end up chopping the cable off. the common mode rejection choke. I now don't have to worry when I am putting 100 watts into this thing, which is very rarely, but I have put the TS520 into it on occasion, so it's nice to, and please excuse the squinting, I've got the sun shining in my face, which is magnificent. Not my face, the sun. We won't have any RF burns off the microphone, hopefully. So that's it. See you in the next video. 7 threes from a VK2 AOE.